Everybody, in this video, we're going to talk about how to divide fractions and how you can help your students develop a conceptual understanding of the process of dividing fractions. So in our video about dividing fractions by whole numbers, we talked about how there's two different types of division, where sharing division is where you take an amount and divide it equally into a certain number of groups and determine how much is in each group. And this is really good for dividing by whole numbers because it's easy to divide an amount into a whole number of groups. It's not as easy to divide it into a fractional number of groups. Measurement division, on the other hand, is where you take an amount and you divide it into groups of a certain size. And this is really good for when you're dividing by fractions because you can take an amount and you can see how many groups of a fractional size you have. So this is the type of division we're going to be using for most of the word problems we'll cover in this video. So when you're introducing the division of fractions to your students, I would highly recommend that you introduce a series of word problems. And I'm going to introduce these word problems to you guys in the order of how I would introduce them to your students. So for this first word problem, it says Mary has 5/8 of a meter of ribbon, and it takes 1/8 of a meter of ribbon to make a hair bow. How many hair bows can she make? Okay, so I want to point out two things about this word problem so that as you're creating word problems for your students, you know kind of the features of what makes this word problem really easy. So the first thing that makes this word problem easy is the fact that the denominators are the same. The second thing is that the number we're dividing by is a unit fraction, which means that there's a 1 in the numerator. So to solve this word problem, we could solve this with a number line, and it works really well for that because we're talking about meters of ribbon, which is a one-dimensional measurement. So we could say, okay, this is the amount of ribbon that Mary has, and it takes 1/8 of a meter of ribbon to make a hair bow. And so that means that we could make 1, 2, 3, 4, 5 hair bows. And essentially what we just did is we took an amount of 5/8 meters of ribbon and we divided them up into groups of 1/8, and we found that she could make 5 hair bows. And so this is the fractional division problem that we just solved. And again, this is really easy because the denominators were the same and because the numerator of the thing we were dividing by was a 1. Now, you could increase the difficulty of this problem once your students understand this type of problem. And you could say, okay, what if it didn't take 1/8 of a meter of ribbon? And what if it actually took 2/8? Well, in that case, that means that she could make 2 hair bows, but she wouldn't quite have enough to make 3. And so this would tell us that 5/8 divided by 2/8 equals 2 whole hair bows. And then because this amount right here is half of what it would take to make the third hair bow, we could say that this equals 2.5. And it's easier if we write this as a improper fraction to see the pattern that's happening here. Because as an improper fraction, 2.5 equals 5/2. So you want to start off with problems that have a unit fraction, and then you can make them a little bit more difficult by changing it to a non-unit fraction. Then, once your students are understanding problems like this, then you can move on to problems with different denominators. So let's say that John has 7/12 of a bucket of flour, and it takes 1/6 of a bucket of flour to make one batch of pancake mix. How many batches of pancake mix can he make? So I would let your students come up with their own strategies and their own thought processes and, discuss those as a class. But I'm just going to quickly go over one way that you could solve this and one way that your students might go about solving this. So I'm going to have this whole rectangle represent a full bucket of flour. And I only have 7/12 of a bucket of flour. And it takes 1/6 of a bucket of flour to make a batch of pancake mix. So I'm going to take this whole bucket and split it up into 6 equal sized pieces because each of those pieces is going to be a bucket of flour. Or sorry, not a bucket of flour. It's going to make a batch of pancake mix. And the 7/12 that represent the amount I actually have, because John doesn't have a full bucket of flour, he has 7/12 of a bucket of flour. This tells me that I can make one whole batch of pancake mix and another whole batch of pancake mix and another one. And then this part right here can make a half of a batch of pancake mix. And so what that tells me is that 7/12 of a bucket of flour divided into groups of 1/6 equals 3 whole batches of pancake mix and a half a batch of pancake mix. And again, the pattern will be easier for your students to notice if you write it as an improper fraction. So 3 1/2, if you write that as an improper fraction, is 7/2. And one of the things that makes this problem easy is the fact that the denominators are factors of each other. So the 12 and the 6 can be represented with the same rectangle relatively easily because a sixth is just 2/12. And so that's a key piece that makes this problem easier. So once your students have done several problems like this, where there's different denominators, but they're factors of each other, then you can move on to doing problems like this one, where the denominators are not factors of each other and they're different than each other. So in this case, we have Malik who has 3/4 of a bucket of sugar, and it takes 2/5 of a bucket to make a batch of cookies. And the question is how many batches of cookies can he make? So again, your students may come up with lots of different strategies, and you should encourage them to find those strategies because that will help them build their conceptual understanding. If it were me, one way that I would model this is with two number lines that are shown on top of each other. Because since these two denominators are very different from each other, like they don't share any factors, it would be easiest if I represent these two fractions on two different number lines. So this amount right here is how much sugar I have, or how much sugar Malik has. And I'm trying to take that amount of sugar and make groups of size 2/5. So I know right off the bat that I'll definitely be able to make one full batch of cookies because that's how much sugar it would take, but I won't quite have enough to make two batches. So I know that 3/4 divided by 2/5 equals one whole and almost two whole batches of cookies. And the question is how much of a fraction of a batch of cookies is that last little bit? Because it looks like it's really close to being two full batches of cookies, but not quite. So the easiest way to figure this out is to find common denominators for these two fractions. So the least common multiple of 4 and 5 is 20. So I'm going to multiply the top and the bottom of 3/4 by 5. And what that means is that I'm splitting up each of these fourths into fifths, which means that the 3/4 bucket, like the 3/4 of a bucket of sugar, is equivalent to having 15/20 of a bucket of sugar. And you can see that is true because if I were to count these, I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 3/4 of a bucket of sugar is the same thing as 15/20 of a bucket of sugar. And then for 2/5, I'm going to multiply 5 by 4, and that's basically splitting up each of the fifths into fourths, which looks like this. Whoops, actually, I just realized this is the fifth. So I'm going to split that in half and then split each of those in half. And that tells me that 2/5 is equal to 8/20. And that makes sense because if I look at this 2/5 that represents one batch of cookies, I have 1, 2, 3, 4, 5, 6, 7, 8/20 in that batch of cookies. Okay, now the whole reason why this is useful is because now the bucket of sugar is split up into small enough pieces that these two sections line up with each other. And so now I can figure out how much of a batch of cookies this amount of sugar will make. So when I look at a full batch of cookies, it looks like it takes 1, 2, 3, 4, 5, 6, 7, 8 twentieths to make a full batch of cookies. And that makes sense because 2/5 equals 8 twentieths. So the amount of sugar that I have is 1, 2, 3, 4, 5, 6, 7 of those 8 of those twentieths. And so what that tells me is the fraction of the a batch of cookies that I can make with this amount of sugar is 7/8. So my answer to this question is 3/4 divided by 2/5 equals 1 7/8. And again, if we write this as an improper fraction, it will make it easier for your students to find the pattern because 1 7/8 is equal to 15/8. Now, I want to do one more word problem that's a little bit different than the ones we've done so far. And it may not even seem like a division of fractions word problem when you first look at it. So in this problem, it says 2/7 of a Lego tower is 3/5 of a foot tall. And the question is, how tall is the entire Lego tower? So I'm going to use this number line to represent feet. So this 1 is 1 foot tall, this 2 is 2 feet tall, 3 feet tall, etc. And so what I know is that 2/7 of a Lego tower is 3/5 of a foot tall. So if I lay this Lego tower on its side, 2/7 of it will come to this mark right here. Now, it would probably be helpful to know what 1/7 of the Lego tower is. So I'm just going to split this 2/7 into two pieces. So I know that this distance is 1/7 of the Lego tower. This distance is 1/7. And it looks like 1/7 is 1.5 fifths. So I could extend this to figure out the height of the entire Lego tower. And I could say, okay, well, here's another seventh. It goes about halfway between 4/5 and 1. Then here's another seventh, which goes to 1 1/5. Then here's another seventh that goes to here. So that's 5/7, 6/7, and this one is going to go right here. So this mark right here marks how tall the entire Lego tower is because I found out how tall 2/7 was, and then I split it down into 1/7 and extended this until I had 7/7. So I know that the height of the entire Lego tower is 2 feet and a little bit more. So what I need to do is I need to figure out, well, what's half of this distance? So this is a fifth, and half of a fifth is going to be a tenth. And so this is going to be 2 and a tenth. And you could also do this for all of the numbers, like if you split these up into halves like this. Basically, we would have like 3/10 for each seventh of the Lego tower. So our answer to this question is 2 and 1/10. Now, how does this relate to fraction division? Well, this answer of 2 and 1/10 is basically what the answer is to 3/5 divided by 2/7, because 2 and 1/10 can be written as 21/10. Now, why does this word problem represent this division problem? So if we look at what this means, we have 3/5 of a foot that's being divided by 2/7. But this doesn't really fit the measurement model of division that we've been talking about, because if you were to use a measurement model for 3/5 divided by 2/7, you would have 3/5 of a foot, and you would see how many groups of 2/7 you could fit within that. And that's not what this word problem is doing. So this word problem is actually using sharing division, where you have 3/5 and you're dividing it into groups or like into 2/7 groups, and you figure out how much is in one group. So the 3/5 of a foot was 2/7 of the height of the Lego tower, and we wanted to find the height of the entire Lego tower. Because if you have a problem like, I don't know, let's say like 15 divided by 3, that equals 5. If you're thinking about this in a sharing model, you have 15 things, you divide them into 3 groups, and you try to find out how many is in each group, which is 5. With fractional division, you have 3/5, So in this case, we had 3/5 of a foot. And we were dividing it into 2/7 groups, and we wanted to figure out how much a whole group was. So the 2/7 was the fraction of the Lego tower, and we were trying to figure out the height of the entire Lego tower. So this would be an example of a word problem that is using sharing division to divide fractions. I wouldn't necessarily recommend starting with this because it doesn't really, I guess I'd say, like, it's not super clear that it's a division problem, but it is a helpful way for your students to practice their reasoning skills. So I wouldn't necessarily use this as an introduction for dividing fractions because you kind of have to explain why this word problem is represented by division. But this would be an example of where you can use sharing division to divide fractions. Okay, so once you've gone through all of these different types of word problems, then you can have your students look for patterns. So the very first word problem we did was the one with the ribbon, where you had 5/8 of a yard of ribbon. We divided them up into 1/8 increments to make hair bows, and we found that you could make 5 hair bows. We also did the problem where we did 5/8 divided by 2/8, and we found out that you could make 2.5 hair bows, which is the same thing as 5 halves of a hair bow. So we did that one. Then we moved on to the ones where we had different denominators. So this was the pancake mix one, where you had 7/12 of a bucket of flour. You were dividing them up into groups of 1/6 to make batches of pancake mix. And we found that you could make 3.5 batches or 7 halves batches of pancake mix. And then the most challenging one was the one where you had different denominators that were not factors of each other. And in this case, we found that when you have 3/4 of a bucket of sugar and you divide it up into groups of 2/5 to make cookies, um, then you can make a whole batch of cookies and almost the second batch of cookies, but not quite. And it ended up being 7/8. So we had 1 and 7/8, which is the same thing as 15/8. And then this last word problem that we did with the Lego tower, that told us that 3/5 divided by 2/7 equals 21/10. So once you have gone through all of these, your students can look at these and start looking for patterns. So one pattern they might find is in our first example, if you do 5 divided by 1, you get 5, and 8 divided by 8 equals 1, which if you write 5 over 1, that's a whole number 5. And so you can just divide straight across. And that is consistent with this example as well, because 7 divided by 1 equals 7, and 12 divided by 6 equals 2. And so if you did a lot of word problems that look like those two, your students might build the concept or the pattern that you can just divide straight across when you're dividing fractions, which is true. You can actually do division of fractions that way. That is an algorithm, but it doesn't always work because sometimes you end up with numbers that don't divide well. Like, for example, if you do 3 divided by 2, you get a fractional number, and 4 divided by 5 is also a fractional number. So, in that case, it isn't very helpful. Technically, it does work in this case because if you do 5 divided by 2, you get 5 halves, and 8 divided by 8 equals 1. And if you have 5 halves over 1, you do get 5 halves. So technically that one does work. And this is the strategy of just dividing straight across. So just like when we multiply fractions, how you multiply the numerators and multiply the denominators, when you divide fractions, you can divide the numerators and divide the denominators if the numbers work out nicely, but sometimes they don't. And so in the case that they don't work out nicely, like in these bottom two examples, you could ask your students to look for other patterns. And then they might notice this pattern. So they might notice that the number 15 is the same as 3 times 5. And the number 8 is the same as 4 times 2. And that looks like that's consistent because if you do 3 times 7, that gives you 21. And if you do 5 times 2, that gives you 10. And if we go back to our other examples, it actually works there as well. Because if you do 5 times 8, that equals 40. And if you do 8 times 1, that equals 8, and 48 eighths does equal 5. So that pattern would work even for the other ones where dividing straight across worked. And if we do 7 times 6, that equals 42. And 12 times 1 equals 12. And if you reduce 42 over 12 by dividing by 6, that does equal 7 halves. And so this pattern is consistent and it will work for any type of division of fractions. And this is an alternative to the typical way that most people learn about dividing fractions. Because the way that most people learn about dividing fractions would be to multiply by the reciprocal. So you do 3/4, and then you multiply it by 5/2 because that's the reciprocal of this fraction. And that gives you 15/8. And notice that the process is basically the same. You're still doing 3 times 5 equals 15, but it's just like a different way of writing it. So when I taught middle school, this is actually something that one of my students taught me, and they called it the zigzag method. So basically, the zigzag method is that you multiply the numerator by the denominator to get the numerator, and then you multiply the denominator by the numerator to get the denominator. So you can't just multiply in this zigzag pattern. And it creates the same result as multiplying by the reciprocal, but I kind of like it better than multiplying by the reciprocal because I've noticed when I've taught the division of fractions, sometimes my students will make a mistake and they'll do the reciprocal of the first number, which doesn't give you the right answer because that would tell you that it equals 8/15, which is not correct. So, um, kind of to summarize, when you're introducing the concept of dividing fractions, I would recommend that you introduce it with a whole bunch of word problems. And the best way to design those word problems is to start off with ones that have the same denominator and you're dividing by a unit fraction. Then you can change it so you're dividing by something that's not a unit fraction. And then you can move on to having different denominators that are factors of each other, then having different denominators that are not factors of each other. And then once you've done several examples and several word problems of all of those types, then you can let your students discover for themselves what the patterns are of how you divide fractions. Um, and there's lots of different patterns. So you can divide straight across, you can use a zigzag method, you can multiply by the reciprocal. But all of those different algorithms will be a lot more meaningful to your students if they came up with the patterns themselves and they conceptually understand what types of situations will cause you to divide by fractions. So if you have any questions, let me know. I hope this video was helpful for you, and I hope you have a good day.